Now another application of dimensional analysis is deducing relation among the physical quantities. Now the method of dimensions can sometimes be used to deduce relation among the physical quantities. For this we should know the dependence of the physical quantity on the other quantities and consider it as a product type of the dependence. For example, we consider a simple pendulum having a bob attached to a string that oscillates under the action of the force of gravity. Suppose that the period of oscillation of the simple pendulum depends on its length L, mass of the bob m, and acceleration due to gravity g. Derive the expression for its time period using a method of dimensions. So here we have a simple pendulum having mass m. So this is a simple pendulum. It consists of a bob of mass m and a string attached to this end, and this bob is free to oscillate. It's free to move to and fro between the extreme position. So we have this bob of mass m, and this is the length of the string, and this bob of mass m is under the influence of gravity. Okay, so if we displace this bob in this direction, so if we displace this bob from this position to this position, then upon releasing it, this bob will again return to this position, to the same position, and it will oscillate to this position. So if we displace this bob in this direction, and if we release it, this will oscillate to and fro in this manner, because this is under the influence of gravity. Okay, so we have a force which is acting downwards, and it is under the influence of this gravity. And the question here is to derive the expression for its time period using method of dimensions. That is, we'll have to find the time taken by this bob after displacing from the mean position to oscillate from this position to this position and again back to this position. So the time taken for this bob to go from this position to this position, again back to the same position, that is known as the time period. And that time period is dependent upon this length. According to the question, the time period depends upon the length, mass, and acceleration due to gravity, which is acting in this direction, g. So this is the acceleration due to gravity which acts downward. So it depends upon mass, length, and acceleration due to gravity. So we know that the time period, so this is the solution. So according to the question, the time period depends upon the mass and the length and acceleration due to gravity. So we'll write the dependence in this way. T is proportional to the mass, and we have to raise it to some power A. Length, again we raise it to some power B, and acceleration due to gravity, again we raise it to some power C. Now these A, B and C, they are unknown, and we'll have to find the value of these quantities A, B and C using dimensional analysis. So here we can write this as K. K is a constant after removing the proportionality sign. m raised to a power a, l raised to a power b, and g raised to a power c. Now the next step is to write the dimensional formula of time, dimensional formula of mass, length, and acceleration due to gravity. Now this k is a dimensionless quantity. So first what we will do is we will write the dimensional formula of this time. Now we know the dimension of time is t itself. So here we have m raised to a power 0, l so here we'll write the dimensional formula of time, which is m to the power 0, l to the power 0, and t. And this will be equal to, now the dimensional formula of mass is m, and this is raised to a power a. And the dimensional formula of length again is L, and this is raised to a power b. Now dimensional formula of this acceleration due to gravity, and this is acceleration. So the dimensional formula of acceleration will be m to the power 0, then we have L, then we have t minus 2 raised to a power c. So since this is raised to a power c, so we have here L to the power c. Instead of writing c here, I write L to the power c and minus 2c. Okay, so c into 0 will be 0. So m to the power 0, L to the power c, t to the power minus 2c. Then we'll multiply this, all these terms here. So mass m to the power a into m to the power 0, this will give you m to the power a itself. Then we have L to the power b into L to the power c. So we have L to the power b into L to the power c. This will have to add. Then we have t, which is minus 2c itself. So here we have m to the power 0, L to the power 0, t to the power 1. Here we have m to the power a, L to the power b plus c, and t to the power minus 2c. So now what we'll have to do is we'll have to equate the dimensions on both sides. Now these are the dimensions. On this side we have a, b plus c, and minus 2c. On this side we have 0, 0, and 1. So here equating the dimensions of both sides, on equating, you can write here on equating the dimensions on both sides, we have, I'll continue it here. So on equating this dimension, we have, you can see here in this equation, in this side we have m to the power 0, in this side we have m to the power a. So here we have to equate the dimension. What are the dimension? 0 and a. So here what we have, a is equal to 0. So on equating dimensions on both sides, we have a to be equal to 0. Then we have here b plus c, this is equal to 0. Then we have minus 2c, this is equal to 1. So this is on equating the dimensions on both sides. A is equal to 0, b plus c is equal to 0, minus 2c is equal to 1. So now our aim is to find a, b, and c. So from this equation what we have is B is equal to minus C. If you bring this on the side, becomes minus C. Then we have the C. In this equation we have C to be equal to minus 1 by 2. So if you bring this 1 to this side, becomes cross multiplication. We have C to be equal to minus 1 by 2. And what is B? You can see B here is equal to minus C. So your B will be equal to minus half. Putting this value here. So what we have is minus into minus. This will give you plus. So your B will be equal to half. Hence A is equal to 0, B is equal to half, and C is equal to minus half. Therefore, your T will be equal to K, then we have M to the power A, which is 0, then L to the power B, which is half, and G to the power C, which is minus half. M to the power 0 is 0, so this will give you K, then L to the power half. Now G to the power minus half I'll write as G divided by G to the power half. Now this half, L to the power half, G to the power half, I can write this as square root. So your T is equal to K square root L by G. And this K, it has a value which is equal to 2 pi. Okay, so the actual value of K is 2 pi root L by G. Again, this quantity will be derived in the chapter oscillations. So the time period is 2 pi root L by G. This is how you deduce relation among physical quantities. In this case, the time period of the simple pendulum. Now the third application of dimensional analysis is conversion of one system of units to another. Now we have learned about the different system of units, namely the CGS system, then the MKS system, the FPS system, and the SI system. Now in calculation, whenever you do calculation or solve any problem, you'll always have to convert the system of unit into SI unit. Suppose your quantity is given in terms of CGS system, then you'll have to convert the CGS system into the SI system. Now sometimes you may be asked to convert the SI system into either CGS, MKS, or FPS system. Now in order to convert these system of unit from one system to another, we'll have to make use of the dimensional formula. Now we know that any physical quantity is expressed as Q is equal to NU. N is the numerical value of the quantity and U is the size of the unit. And depending upon the system of unit, N can be different and U can also be different. Now this we have done, I think, in the previous video. If your U is large, then N will be small. If the size of your unit is small, then the numerical value of the quantity will also be large. For example, if the length of an object is Suppose you take the length to be equal to 100 centimeter. Now in terms of meter, your length will be equal to 1 meter. Now here the size is large, the size of the unit is large, but the numerical value is small. In this case the size of the unit is small, but the numerical value is large. But both these, they are same. So here your 100 centimeter, this is equal to 1 meter. So this one is 100, this is 1, this centimeter, and you have meter. So 100 centimeter is equal to 1 meter. Now in general, if we have any physical quantity, then you denote that physical quantity as N1U1. You express it as N1U1, and it may have a different system of unit, N2U2. Okay, so we have here, in this case we have the centimeter, the CGS unit, and in this case we have the SI unit, which is meter. So in this way you can express the physical quantity as N1U1 is equal to N2U2 in general. N1U1 is equal to N2U2, where U2 is a different system of unit from the U1 system. Now in order to convert one system to another, we have to make use of the dimensional formula. Suppose a quantity has a dimension of A in mass, B in length, and C in time. Okay, suppose A, B, C, these are the dimensions of the physical quantity. A, B, C, these are the dimensions of physical quantity. Dimensions of the quantity which we want to convert from one system to another. So A, B, C are dimensions of the quantity in the mass. A is in mass, B is in length, and C is in time. Then instead of this U1, I'll write the dimension of mass, that is A M1, the dimension of length, that is B L1, and the dimension of time, which is C in T1. So this is the dimensional formula of the unit or the quantity. Then we have N2, and here also we have M2, A, then L2, B, and T2, C. So you can see that instead of the size of the unit, I've written the dimensional formula. Now M1 is now suppose N1 is given, U1 is also given, okay, and you'll have to convert the system of unit from U1 to U2. Okay, so from one system, from U1 system to the U2 system. So in order to do that, we'll have to find this numerical value in terms of this unit. Okay, so if you're asked to convert U1 to U2, then you'll have to find this N2 because this is unknown. Your N1 is given, and U1 is given, and U2 is also given. So to do that, we'll have to use this formula. Now N2 in this case will be equal to N1. Now you bring this one here, it becomes this one, you bring it here. So we have M1 by M2. Then we have the same power, A, same dimension. Then we have L1 by L2, and again we have the same dimension, C, or B, sorry. We have the same dimension B, and we have T1, T2, again same dimension C. So you can use this equation to convert one system of unit to another system. So you'll understand this better by an example. So if we take an example, suppose the force acting upon an object is given to be equal to 1 Newton. Suppose if we have an object, so we'll take an example. So we have an object of mass m, and you're applying to this object a force which is equal to 1 Newton. Now Newton is the SI unit of force, and since force is equal to mass into acceleration, the SI unit of mass is kg, and the SI unit of acceleration is meter per second square. So kg meter per second square, this is known as Newton. So your Newton is equal to kg meter per second square. So we are asked to convert this 1 Newton, convert 1 Newton into another system, which is the CGS system, dyne. So we will have to convert 1 Newton into dyne. Now dyne, this is the CGS system of force. You will have to convert SI system into CGS system. Now we'll have to use this formula here. Okay, in order to convert 1 Newton into dyne, we'll have to use this formula. So here the numerical value N1 is given to be equal to 1, and here this is the unit which is in M1, L1 and T1. So M1, now since it is in SI, the SI unit of mass is in kg, and length, the SI unit is meter, and time, the SI unit is second. So we'll have to convert from SI to CGS, and from this SI to this CGS, and this in CGS mass is in gram, length is in the CGS we have centimeter, and time is in second. So let's use this formula to convert this 1 Newton into dyne. So here, okay, it's given that N1 from the formula, from this question, N1 is equal to 1. Then here Newton is in SI unit. So here your M1, this one will be in kg. So M1 is mass, M is the mass, this will be in kg. Then we have L1, this will be, what is the SI unit of length? Meter. So we have meter. Then we have T1, what is the SI unit of time? Second. So here N1 is equal to 1, M1 kg, L1 meter, and T1 is second. And we'll have to convert into dyne. Now N2, how much is N2? We'll have to find this one out. We'll have to convert 1 Newton into dyne, so we'll have to find the numerical value in terms of dyne. So this you'll have to find out using this formula. Now what is your M1? M2. M2, this dyne is the CGS. So M2, the CGS system of mass is grams. CGS, we have grams. Then L2, CGS, this is centimeter. And time, this is second. So we have got M2 to be gram, L2 to be centimeter, and time to be second. So CGS, and this is the SI unit. So we have got the values, these values of M1, L1 and T1, M2, L2, T2 and 1. Now we'll have to know the dimension of force, the dimensional formula of force. Now we know that the dimension of force, I'll write it here, dimensions of force, or I'll just write the equation of force. So here F, I think this we have done in the last lecture video. So F, we have mass to the power 1, then length to the power 1 and time to the power minus 2. This is the dimensional formula of force. So here force has a dimension of 1 in mass, 1 in length and minus 2 in time. So this A is equal to 1. In terms of length, B is equal to 1 and C is equal to minus 2. Okay, so remember this formula, I'll use it. First I'll write A, B, C here. So here we know now that A is equal to 1, B is also equal to 1 and C is equal to minus 2. So these are the dimensions of force, 1 in mass, 1 in length and minus 2 in time. So the next step is to put all these values in the earlier formula. So we have N2, this is equal to, we put it in this formula, I'll write the formula first. So we have N1, again to M1 by M2 to the power A. Then we have L1 by L2 to the power B. Then we have T1 by T2 to the power C. So we'll put all these values in this formula. So N1, this is equal to 1. Now M1, this is kg, and M2, this is gram, so we have kg. Then we also have M2 to be equal to gram. Then we have L1, this is in meter. L2 is in centimeter. Then we have T1, which is in second. And T2 is also in second. Then we have A to be equal to 1. Then we have B to be equal to 1. Then we have C to be equal to minus 2. So we have put all the values in the formula. Now we'll have to convert, remember, from SI to CGS. So instead of kg, I'll have to convert into gram. This one into gram. Meter into centimeter. And second, leave it as it is because this is also second. So your kg, kilogram, this if convert into grams, it will be 10 to the power 3 grams. So instead of kg, I'll write 10 to the power 3. Then G. So we have 1. Then meter. Now 1 meter I've shown you earlier. 1 meter is equal to 100 centimeter, isn't it? 100 centimeter is equal to 1 meter. So here your meter, you can write this as 100 or 10 to the power 2 centimeter. 1. Now in this case, what you do is we have second here, we have second here, so what you do is you can cancel them, and this will be equal to 1. Okay, and 10 to the power 1 is 1 itself, so here we have 1. And again here also, since we have already converted, we can cancel this GG, centimeter, centimeter. So the numerical value in terms of CGS will be 1 into 10 to the power 3 into 10 to the power 2. And with this one also it will be the same. So 1, we have 1, 10 to the power 3 into 10 to the power 2. Okay, so 1 in this one, 1 into 10 power into 3 will be 3, 1 into 2 will be 2. So this is what we have, and this one 10 into to the power 3 into 10 to the power 2. This will give you 10 to the power 3 plus 2 will give you 5. So this is your N2. Hence your Newton, hence your Newton, 1 Newton, 1 Newton, this will be equal to how much dyne? N2 is 10 to the power 5 dyne. So here you have N1, U1, N2, U2. So remember, whenever you have to convert one system to another system, you have to find the value of this N2 if you're using the dimensional analysis. You can also convert one system of unit to another system without using dimensional analysis, and you can do that by using this table given here. So in this table we have submultiples and multiples, and we have prefixes and symbols and their values expressed as powers of 10. So in the submultiple we have the first prefix, which is deci, the symbol is d, and the value is 10 to the power minus 1. Then we have centi, which symbol is c, and the value is 10 to the power minus 2. Then milli, and the symbol is m, and the value is 10 to the power minus 3. Then we have micro, and the symbol is mu, and the value is 10 to the power minus 6. Then we have nano, and the symbol is n, and the value is 10 to the power minus 9. And we have pico, and the symbol is p, and the value is 10 to the power minus 12. And we have femto, the symbol is f, and the value is 10 to the power minus 15. And we have atto, and the symbol is a, and the value is 10 to the power minus 18. Then we also have the multiples, and the first prefix is deca, and the symbol is da, and the value is 10 to the power 1. Then we have hecto, the symbol is h, and the value is 10 to the power 2. Then we have kilo, k, then 10 to the power 3. Mega, capital M, 10 to the power 6. Then we have giga, capital G, the value is 10 to the power 9. Then we have tera, capital T, the value is 10 to the power 12. Peta, capital P, 10 to the power 15. Then exa, capital E, 10 to the power 18. So you can use this table to convert. You memorize this table. You at least memorize deci, centimeter, milli, micro, nano, and for multiples deca, hecto, kilo, mega, giga. Okay, you memorize these value of these prefixes. So for example, I'll take 10 centimeter or 100 centimeter. Now 100 centimeters. So this is centi. You can see here. This is centimeter. So meter is like the base unit, and centi is the prefix. So instead of centi, I can write it by its value. So 100. Now what is the value of centi? The value of centi is 10 to the power minus 2. So instead of c, I'll write 10 to the power minus 2 meter. So here what we have is 100, then the 10 to the power minus 2, this can be written as 10 to the power 2, or 10 to the power 2 meter, and 10 to the power 2, this is nothing but 10 to the 10, which is 100. So you cancel it and you get 1 meter, which we have already known. 100 centimeters is equal to 1 meter. You can see here I've got this value by writing this centi with its value, which is 10 to the power minus 2. So here you have, do you see any centi? No, because I've written it in terms of its value, 10 to the power minus 2. And again, let us take some more example. Say 10 kilometer. 10 kilometer. Now how much is this equal to? Now 10 kilometer. Now kilo, K is a prefix here, and meter you can see is the base unit. So here the value of kilo, K, is 10 to the power 3. So instead of K, I can write 10 to the power 3 meter. So this will be the value of the length 10 kilometer in terms of meter. So 10 kilometer is equal to 10 into 10 to the power 3 meter, or if you multiply 4 meter. You can see here I've converted kilometer into meter. Now you can also convert this meter into kilometer. So let us take this example, 10 to the power 4. 10 to the power 4 meter. 10 to the power 4 meter. Now I can convert this into kilometer. What I'll have to do is, you have 10 to the power 4, then I'll add km. Okay. So this is kilometer. Because I've added this one, I'll also have to divide it. K. Alright, so here K can be cancelled, so it's the same as meter. So this one, km by K, is the same as 10 to the power 4 meter. Now here what I'll do is, in this denominator I'll write it with its value. So instead of this K, I'll write 10 to the power 3, which is the value of K. And you have 10 to the power 4. This 10 to the power 3, if we bring it to the numerator, it will become 10 to the power minus 3. And we have this km. So here 4 minus 3, this will give you 1. So this 4 minus 3 will give you 1. So 10 to the power 4 meter is equal to 10 kilometer, which is the reverse of the earlier one. Then same for this meter also. I can convert meter into centimeter. I can do the reverse also. So 1 meter, again what I'll have to do is I'll have to add centimeter here, C, and also here also I'll have to divide it by C, and again here I'll do is, instead of C I'll put the value of C, which is 10 to the power minus 2, and if I bring this 10 to the power minus 2, if we bring it to the numerator, this minus becomes plus. So here 1 meter is equal to 10 to the power 2 centimeter. Okay, so you can convert one system into another system by using this table given. Okay, so remember, if you have to add the prefix, then you have to divide it with its value. So if you add here centi, then you have to divide it by 10 to the minus 2. If you add deci, then divide 10 to the power minus 1. If you add milli, you divide it by 10 to the power minus 3. If you add micro, you divide also by 10 to the power minus 6 with its value. Similarly here also, the multiple, if you add say mega, then you have to divide this by 10 to the power 6. If you add giga, then you have to divide it by 10 to the power 9. So if you add this prefix, then you have to divide it by its value. So that's how you convert one system into another system.